Fusion Mobile, quality e-learning experience on the go.
Welcome to Fusion Mobile e-learning clinic. My name is Sonia Lalo and I'll be guiding you through the chemistry course. In this particular lesson, we'll be considering air and air pollution. We'll look at the constituents of air. We'll talk about atmospheric oxygen, the atmospheric carbon dioxide, the atmospheric nitrogen, and we'll consider noble gases. Then we'll look at water vapor in air. Then we'll look at air, how it dissolves in water. Then we'll consider air pollution, pollutants, and then control of air pollution. Alright, let's get started. So when it comes to mind, when they ask you what is air, the question, usually people know what air is. We can all tell what air is. It is this thing that we suck in through our nose and it goes into our systems to energize our body and do a lot of good, wonderful things for us. But ultimately, what is air in the real sense of it? Air is a mixture of gases which is found around the atmospheric region of the Earth. It's a mixture of gases found in the atmospheric region of the Earth. Our air on the Earth is different from the kind of atmosphere they have in other planets. And our air in the Earth is composed of several components, such as the nitrogen. And nitrogen having a constituent of about 78%. We also have the oxygen. The oxygen occupying just about 21%. Some people do argue 20.8%. We have the carbon dioxide, also known as carbon dioxide, occupying about 0.03%. Then we have the rare gases. Of course, we describe rare gases also as noble gases, about 1%. Then we have water vapor. We also have dust particles. Now, water vapor and dust particles, they are variable. They are variable in the sense that they depend on the location in which you are at the moment. Imagine you are driving on the road. Of course, the dust, if it is an untarred road, the dust level will be high. So that is also showing you. And also, on the particular, at the equator region, we do have a more humid temperature. We do have humid weather conditions compared to at the polar regions. So we at the equator regions, we do have more water vapor in our air compared to people at the polar regions. So how do we confirm? Well, we talk about the composition of air. This is the list. So what is the function of each of these constituents of air? Let's start with oxygen. Oxygen. Of course, we know man, animals, plants need oxygen to survive. Oxygen is our major respiratory gas. It's the gas we inhale to keep our bodies running. Other than inhaling this gas, what other benefits, what other thing does this gas do in nature? Oxygen is a compound that allows burning. Oxygen allows burning. So if you are going to burn any substance, you need oxygen for it to burn. Otherwise, burning would not occur. Apart from burning, oxygen also is responsible, is very needful for corrosion process. Is needful for corrosion. Of course, if there is no oxygen in a particular system, corrosion cannot occur. That's why if you put your metal in a particular place, after a while you see it starts corroding, shedding off. That's because it has been in contact with oxygen and some other components which aid corrosion. So we said oxygen is responsible for both corrosion and burning. So let's take a quick look at the similarities and differences. What is the role of oxygen in both of these processes? Well, in terms of burning and corrosion actually liberate heat. Burning and corrosion liberate heat. So yes, heat is more felt in burning than in corrosion, but both of them do liberate heat energy. Burning is a fast, rapid process, while corrosion is a slower process. It takes a while it may take up to a year or 2 years before a particular metal would start to corrode. Corrosion is a slow process, and both burning and corrosion are oxidization process. They are oxidization processes. So you see, oxygen is being added to the substance. So both of them are oxidization processes. All right, we've talked about composition of air, and we've also spoken about the atmospheric oxygen. So we'll take a short break. In this short break, we'll be asking you some questions. Some questions will be displayed on your screen in a few. We'll test your knowledge. We want to know how much of what we have taught so far you understand. We'll be right back. So, welcome back. We talked about composition of air, and we also mentioned the atmospheric oxygen. So let's go into carbon dioxide, that's carbon dioxide. Carbon dioxide in air occupies about 0.03%, which we discussed earlier. Now, carbon dioxide is used, it's a byproduct, it's one of the products of respiration. When we breathe in oxygen in our respiration, we breathe out carbon dioxide as in a larger quantity. Yes, like one of my teachers do tell us, we breathe in air, we breathe out air. But the carbon dioxide that's carbon dioxide in the air we breathe out is more than the carbon dioxide in the air we breathe in. Now, apart from respiration, what else do we find carbon dioxide of use? Carbon dioxide comes to play also in the production of food by green plants. Production of food in green plants, where we see the chemical reaction for photosynthesis, which shows CO2 plus H2O would give us C6H12O6 plus O3, and this is 6, and this is 6. So the chemical equation for photosynthesis, this happens in the presence of sunlight. So green plants use carbon dioxide to produce their food, which we eat, that's sugar. Of course, we'll talk about the nitrogen, atmospheric nitrogen. Atmospheric nitrogen occupies the largest volume in the atmosphere. In our atmosphere, that's about 78%, and that's a lot more than half of all the air. So what are its uses? Nitrogen is actually inert. It does not much in the air, only a few things. Basically, it dilutes the air. It dilutes the air. How do I mean dilutes the air? If our air were to be filled with a larger volume of oxygen, we would not be able to light anything without being burnt. Even when air is blowing, there's still a chance that you light a matchstick and you get burnt by the matchstick. But when the air is filled with so much of oxygen, the oxygen sets everything ablaze and it burns like very fast. So the nitrogen in the air helps to curtail or limit, reduce the effect of the oxygen in air. Apart from that, burning, it also curtails the rate of corrosion, the rate at which materials do corrode. So if actually substances were left to be in pure air, that is pure oxygen, it will corrode at a faster rate than when it is in our atmospheric air. What is the job of the noble gases in air? Noble gases also help us to fix the air. They are all air fixers, air regulators. They do not partake in any reaction, so they help to curtail everything. They help to keep a kind of stability in the air. Water vapor in the air. Water vapor in the air varies. It varies from location to location, and it also varies on based on temperature of the region. It based on temperature of the region, where when the place is very hot, there is a chance that the environment will be humid. When we say an environment is humid, it means that it contains a high volume of atmospheric water. That is, water vapor in the air would be high. That's why when you have, if you collect the air from a humid place and you take it to a cooler place, you see that it would precipitate. It will bring out droplets of water. And that is one of the things that happen in our air conditioning systems. Why some of our air conditioning systems do drop water outside, when you see droplets of water, it is because the water vapor from the air inside the room has blown and it has been cooled, and the liquid air, the gaseous air, which was a vapor, has been converted to liquid. So also we talked about this. Yes, let's talk about air dissolving in water. Of course, we said earlier that all animals breathe in air, and that does not exempt the sea animals, that is the fish, the other Pisces. They also breathe air. And how do they get their air? Well, air is sparingly soluble in water. Air is sparingly soluble in water. So when air scrapes to the surface of the water, it dissolves in water and it soaks the water such that it can provide air to the animals living within it. And also, when the animals, the sea plants, are also producing their food, they also liberate oxygen, just as is suggested by the photosynthesis expression. All right, let's talk about air pollution. What do we mean by air pollution? We already talked about air. We all know what air is. So what is pollution? Pollution is the release or introduction of things which are not conducive for a particular environment. So when we're talking about air pollution, we're talking about pollution inside the air. That is the release of substances which are not good for the atmospheric environment. So when we think about it, what are those things that we can classify as air pollution? What causes air pollution? Well, air pollution simply is created by the injection or introduction of certain compounds into the atmosphere. Introduction of certain compounds into the atmosphere. And these compounds are generally regarded as pollutants. So, what are the air pollutants? We have a couple of them. There is no actual priority list, but I would put them this way. So, let's take a look at this. We have a particulate matter. Particulate matter, this refers to dust particles, solid substances which you can find in air. When you are walking on the road, and especially on an untarred road, and a vehicle drives past you, especially on a sunny day where the road is so dry, you just see so much of dust to just rise up into the air and you get ingested. And when you ingest it, it makes you cough, it gives you catarrh, it might even cause some even very deadly diseases, nasal and respiratory diseases. So these particular matter are not so healthy. Apart from that, even in your suit, the soot coming out from your generator exhaust, it also contains, you see, black particles. It's also a particulate matter. Particulate matters. Also, you see people who smoke. You see in fact, you can pick it out. You can actually see these particular compounds in the air. So these are particulate matters. Also, we have the oxides of carbon. Oxides of carbon. There are two major oxides of carbon. We have the carbon 4 oxide. We have the carbon 2 oxide. The carbon 4 oxide is, yes, it is a pollutant, but it is not a severe pollutant as to carbon 2 oxide. Carbon 4 oxide can stay in the air and just be there without affecting you. If you don't have enough oxygen, yes, it could affect you. But carbon 2 oxide, rather than it just being there in the air, it is also consuming the available oxygen in the air, trying to turn itself into carbon 4 oxide. That is, it is consuming the oxygen available to form another pollutant. So that makes it even very, very dangerous. Of course, we have oxides of nitrogen and sulfur. Oxides of nitrogen and sulfur, we have NO, we have N2O, we have NO2. For nitrogen, we have SO2, we have SO3 for sulfur. Now, all these oxides are acidic in nature. They are acidic in nature. Even the carbon oxides, they are acidic in nature. So some of these substances can even cause what is known as the acid rain. Acid rain, which can actually ruin some of our crop plants and cause a lot of havoc in the community. We also have the hydrocarbons. The issue of hydrocarbons is a very serious one, because it is one of the things that we use as our major means of energy in these last few years. We talk about hydrocarbons. Hydrocarbons are most of our petroleum products are made from contain hydrocarbons. In fact, all our petroleum products contain hydrocarbons. And we see houses running on generators, vehicles running on the road. You see that in cities, air pollution is usually on the high side compared with in the rural environments, because of the consumption of all this use of all this heavy machinery which do use hydrocarbons to operate. Also, we have the chlorofluorocarbons. The chlorofluorocarbons are chemical compounds which are used in making of our effluents, our sprays, and refrigeration gases, our body spray, our refrigeration gases. We find chlorofluorocarbons in them. And what do these things do? These things have so terrible effect that they consume the ozone layer, they deplete the ozone layer, exposing us to the hardship that the sun is holding back for us. So chlorofluorocarbons actually have the potential. They are known as they're known as the global warming gases. They are the ones that actually initiate what is known as the global warming. They cause an increase in temperature generally. They cause a rise in temperature all over. So these are some of the major air pollutants. These are the major air pollutants. We also have other substances. So how can we control air pollution? How can we control air pollution? Number one is to adhere strictly to regulations. Of course, these regulations have to be created such as to write out or to cancel out these pollutants. For instance, it has been in the law for about 10 years plus that fluorocarbons should no longer be used in refrigerants as refrigerants, and they should be cut off from the production of air fresheners and body sprays. Well, if our manufacturers have been obeying this, we would have a reduction in the effects of these particular substances on our atmosphere. Also, the use of designing of proper engines and proper maintenance of your vehicles, of engines. Design of proper engines in the sense that you can design engines that will combust fuel completely, combust hydrocarbons to a very reasonable extent, such that it will leave no particulate matter or incompletely combusted hydrocarbon. Then we would be reducing the rate at which we will be polluting our environment. Also, people should be educated on the causes and how to control these causes. Of course, we see people go into bush burning and all those things. If we actually reduce deforestation, we might actually be able to encourage a renewal of the atmosphere. That is, whatever oxygen is being depleted from the atmosphere, it can be renewed by the trees that is being planted. So afforestation can actually be a way of controlling air pollution. All right. In this lesson, we have looked at air and air pollution. We discussed the components of air, that's nitrogen, oxygen, carbon dioxide, rare gases, atmospheric water, that's water vapor, dust particles. And we talked about their percentages. We talked about the atmospheric oxygen, its use. We talked about the carbon dioxide and its use, the nitrogen, the noble gases, the water vapor in air. We also explained that air actually dissolves in water, and we talked about air pollution. We explained that air pollution is simply the disturbance of the state, of the proper state of air, introduction of unwanted, undesired components into air. And these components are described as pollutants. Of course, we also discussed how to overcome air pollution. So, having spoken about all of these things, in a few seconds, some questions will be displayed on your screen to test your understanding of what has been taught in this lesson. You are required to answer them. And if there is any part of the question which is challenging, you can go over the video one more time for clarification. Thank you.